Hi everyone. Today we're going to study length of an arc and area of a sector. Let us start with length of an arc on a circle. The length of an arc on a circle is illustrated by this figure, and let us have a formal definition. In a circle of radius r, the length of an arc S, subtended by an angle theta in radians, is given by the formula S. This is the S, that is the arc. S equals the radius times the angle in radians. Please note, the arc corresponding to one full revolution of a circle is the circumference. Let us have example 1. Find the length of an arc of a circle of radius 12 inches, subtended by a central angle of pi over 4 radians. Let us first collect the given. The radius is 12 inches. And the angle in radians is pi over 4. The formula is S equals R times theta. Then we will substitute now the values. The R becomes 12 and the theta is the value pi over 4. Then we will simplify further. We can cancel this 12 and 4, it becomes 3, and then we will copy the pi. So the S, the length of the arc, equals 3 pi, and we will not forget the unit of measurement, that is inches. So our final answer is 3 pi inches. Let's have example 2. Find the arc length along a circle of radius 10 units, subtended by an angle of 120 degrees. Let us collect the given first. The radius is 10 units. The angle is given in degrees, that is 120 degrees. The formula is S equals R times theta. But we must convert this angle as expressed in degrees into radians. The conversion formula is here from degrees to radians. We will write again the formula, and for the degrees we're going to put the 120 value here. And then we will simplify further. We can reduce this 120 over 180 into lowest term. We will divide by 60. So the 120 divided by 60 is 2 over the 180 divided by 60 is 3. And this is equal to the right hand side radians over pi. And then this pi we will cross multiply on the left side. So we will now have 2 pi over 3 equals radians. So this is now the value of this 120 degrees, which is equal to 2 pi over 3. Now we can proceed with our computation of the arc length. We will now substitute the values on the formula. So S equals, the radius is 10, times the angle that must be in radian. We will now use the 2 pi over 3. From here, we will simplify further. 10 times 2 pi will get 20 pi over the denominator 3. We will just copy. So the arc length equals 20 pi over 3. We will simply attach our unit of measurement In here, it simply says units, so we will copy that. This is our final answer. Let's go now to area of a sector. First, let us define a sector. The sector of a circle is the area bounded by two radii, that is the plural of radius, and an arc. Here is a picture of a sector. Let us go now to area of a sector. The area of a sector of a circle with radius r, subtended by an angle theta in radians, is given by the formula A equals 1/2 theta r square. Please note the sector corresponding to the full revolution of a circle is the area of the circle. Let us have examples. Example 1. Find the area of a sector of Shinas roundabout, approximately of radius 10 meters, subtended by 2 radians. Given is the radius, that is the 10 meters, and the angle in radians is 2. Using our formula A equals 1/2 theta r square, we will now substitute the values. So A equals 1/2, theta is now 2, times the r square, the radius is 10, and we copy the square. We will simplify further. We can cancel this 1/2 and the 2, and then we will expand the 10 square. So the area is 100. For the units, we're going to write square meters because we are dealing with area. This is our final answer. Example 2. An automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees, as shown in the figure. What is the area of the sector of grass the sprinkler waters? Let us collect the given. The radius is 20 feet and the angle is given in degrees, that is 30 degrees. Then we will write our formula for the area of a sector. But first, let us convert the angle in radians. The conversion formula is here. Let us now substitute the value. 30 over 180 equals radians over pi. Let us simplify our left-hand side. The 30 over 180, if we divide both by 30, it will be reduced to 1 over 6 equals the right-hand side is radians over pi. Now this pi we will cross multiply to the left-hand side. So 1 times pi will be pi over 6. This is the value of this 30 degrees in radians. We can now substitute the values in our area formula. So A equals 1/2, the theta, we will now use the value in radians, the pi over 6, times r square, our radius is 20. So we put it here. We will simplify further. We can combine the 1/2 and the pi over 6. We multiply 2 by 6, it becomes 12. So here we have pi over 12, and the 20 square is 400. We will simplify further. We can cancel the 400 and the 12. We can divide each by 4, so the 400 becomes 100. Then we copy the pi all over. The 12 divided by 4 is 3. So our answer here, the area is 100 pi over 3. For the units of measurement, we will write square feet or feet square to denote an area. This is our final answer. I hope we learned something from this video. See you again next time.